Hello, and for discussion 6, I was version 2. So I chose the weights and I chose N as my 40. So my mean for my first one was 12.57, my standard deviation was 3.41 pounds, my minimum was 5.7 pounds, and my maximum was 20 pounds. So right here I did my SE, and it says that we can actually get a good estimate of the standard error of the sampling distribution with using N Gallups, since this is the standard error and basically standard deviation of the sample and not the whole population. So for my standard error, I did my standard deviation divided by the square root of N, which is 40 for me, and I got 0.54. Then for my lower limit, I got 11.661, and my upper limit, I got 13.471. And how I did this is I went to a t-table and I found the value at N equals 40, and because I needed the 90% confidence, so I found it for the appropriate one, and I multiplied that by the SE, and then I did the mean minus the SE times by the number that I found on the T-chart. And so this is a relatively symmetric but slightly skewed to the right. Doesn't have many outliers, and it's relatively normal, no extreme outliers or large skews. And so for this one, we are 90% confident that the average weight of the Gallups on planet Z is between 11.66 pounds and 13.5 pounds. So then for the next one, I kept the N, which is the sample size, the same. All I'm doing differently here is I got a new sample size, and here we're actually going to find the 95% confidence. So for this one, the mean was 14.09 pounds, standard deviation was 3.58 pounds, the minimum was 4.3 pounds, and the maximum was 20.60 pounds. So also I did my SE by doing my standard deviation divided by the square root of the N, which was 40, and I got 0.5660. I said that this is slightly skewed left, relatively normal distribution. If anything, I might say 4 might be a slight outlier, but it's not a major outlier. And so here I kind of show more of what I did for my lower limit. I got 12.94. And I looked up this value right here on a t-table, and you can see how I did my math, and I got 15.24 for my upper limit. So we can say that we are 95% confident that the average weight of the Gallups on planet Z is between 12.94 pounds and 15.24 pounds for this situation. For the next one, we're going to find the 99% confidence. I did the exact same thing with the sample size and just drew a new sample. And so for my standard error, I got 0.6609. Lower limit, I got 11.213 pounds. Upper limit, I got 14.787 pounds. And I said slightly skewed to the left. Other than that, normal, nearly normal. 4 could be a small outlier. Again, I could also say that 22.5 could be a small outlier as well, but nothing major. And I can say we are 99% confident that the average weight of the Gallups on planet Z is between 11.21 pounds and 14.79 pounds. And here I did a whole number line in one. So the blue one was the first. Triangles equal the mean, and here is my 90% confidence level. Green is the second one, which is right here. Here's the mean, and here are my intervals. And orange is the third. Here is the mean, and here are my intervals. And then also just answering a few questions. It says to include a sentence on why your 3 sample means do not have the exact same value. And I said they don't have the same value because it is different, and pulling from different samples at random is the key word. It depends on the chosen sample and not the population as a whole. If it depended on the population of the whole, we would use the same mean. But since this is pulling at random samples, we're going to have 3 different means. Another question was, which confidence interval would you prefer? I said the 99% because it gets more of the population. Since it is a higher percent, we can also assume it is a good suit for the overall population because it is dealing with 99% of the population, leaving just 1% the population that doesn't get this. And trying to think if I missed anything else. So I think that is it. Let me know if you guys have any questions. Oh, I was just gonna also discuss how the 3 confidence intervals are similar. I said how they differ, but they're very similar on the line because we are only just going a few. The sample is the same size, we just have a few different variations, and it all just depends on what our SE is and what the standard deviation of that sample size, not the population, but of the sample size. If you have any other questions than that, please just let me know, and thank you for watching.